So we're going to look at fractional distance in this lesson. And what fractional distance is, it happens when we have a distance between 2 points on a coordinate plane or even on a number line. We're going to do the examples on the coordinate plane. And we want to find a point that is located somewhere on that segment or that line between those 2 points, but a certain distance away from one of the endpoints. So a fraction of the entire distance. If I gave you 2 points and said find the length of that segment or find the distance between these 2 points, you would use the standard distance formula. The d equals square root of the difference of the x's squared plus the difference of the y's squared. But we want to find a fraction of that distance. But not only are we looking for a fraction of that distance, we want to know the point that is located at that fraction of that distance. So we're not actually going to find the full distance itself. So what we're going to do is we're going to look at each individual set of coordinates individually. We're going to look at the x's and we're going to look at the y's. So the first question says, let's find the point that is 2/5 of the way from 2,4 to 12,19. So I'm looking for something that is 2/5 from, that means this is your start. You always have to designate your starting point. I want to go 2/5 of the way from 2,4 to 12,19. So how do I figure that out? Well, the first thing I need to do is I need to figure out how far apart the x's are and how far apart the y's are. So let's look at our x coordinates, 2 and 12. All right, so we want to see how far apart are 2 and 12. So 2 and 12, I'm going to take the absolute value of the difference. I can probably tell they're 10 apart, but I'm going to take the absolute value of the difference. Remember that, 12. That's how we find the distance. So 2 minus 12 gives you negative 10. And when you take the absolute value of negative 10, you get 10. So I know that my x's are 10 apart. Okay, these are my x coordinates. So let's look at my y values now. My y values go from 4 to 19. So for my y values, I'm going to do the same thing. I'm going to find the distance between 4 and 19. So 4 minus 19 is negative 15. So my y values are 15 apart. So that's how far apart each of these is. My y values are 15 apart and my x values are 10 apart. But I don't want to go the full 10 and I don't want to go the full 15. So the question is, if I don't want to go the full 10 and I don't want to go the full 15, how do I find 2/5? Well, whenever you find a fraction of something, you multiply that fraction times that value. So what I'm going to look at here, I don't want to go 10 units across from 2 to 12. I'm not going all the way from 2 to 12. I'm going to go from 2 to 2/5 of the way. So I'm going to take 2/5 and multiply it by 10. I can put 10 over 1. Remember, you're multiplying fractions. That gives me 20 over 5, which is 4. So I actually only want to move 4 units away from my starting point. So let's now look at what that ends up being. So instead of going 2 plus 10 to get 12 and going the full 10 units, I'm only going to go 2/5 of that distance, which is 4. So instead of 2 plus 10 to get to 12, it's 2 plus the 4 units. And that puts my x-coordinate at 6. So I'm going to go ahead and put the coordinates here. So my x-coordinate I'm looking for is 6. So now let's find the y value. So for my y value, I want to find 2/5 of the distance, 15, because I don't want to go the full 15 from 4 to 19. I only want to go 2/5 of the way. So 15 times 2 over 5, that gives you 30 over 5, which is 6 units. So I want to only move, instead of moving 15 units from my start, I want to move 6 units. So I'm going to go 4, which is my original y, add 6 units, and that puts me at 10. So the point that is actually 2/5 of the way from 2,4 to 12,19 is 6,10. Again, we found out how far apart these were. 2 and 12 were 10. 4 and 19 were 15 apart. That's the full distance. I only want 2/5 of the distance. Now you will be given, there is a formula that you can use to plug in. And you can use this formula. And this is the fractional distance formula. And we haven't used this because you don't necessarily need it. But we're going to give it to you anyway. The fractional distance formula says that your starting x-coordinate plus k times the distance and your two x's is your first coordinate, and your other coordinate is going to be your starting y value plus k times the difference in your y's. Now this looks confusing. K is your fractional distance factor, okay? That's your fractional distance. K is the fractional distance, so the K is the 2/5. So that's saying that we're going to take 2/5 in each of these cases, and we're going to multiply 2/5 times the distance between the two, okay? The distance between the two, and this meaning x2, how far, I mean the larger of the two. So how far was it from x to x? Well, 12 minus 2 if you want to do it in here, or we can do the absolute value, which is also a possibility. But we want to know how far apart these two are. Multiply it by the fraction, which is what we did. We got 4 units instead of 10, and then what did we do? We added it to the original x-coordinate. So this is actually the two fractional distance formulas. The original x value plus the fraction times the distance the x's are apart. The y-coordinate is the original y value plus the fraction times the distance the y's are apart. So let's try the next one. I'm going to leave the fractional distance here in the frame. And let's do this using the fractional distance, and then we'll do it the other way. So let's use that fractional distance formula first. So I'm looking at my 2 points. Okay. The fractional distance formula says I'm going to go from -2, 0 to 7, 11. 7, 11. Get something to drink. So this is your start because of the way the question is written. That's your start. So that's going to be your x1 and your y1. Okay? So let's look at the formula. The formula says to find the x-coordinate, I'm going to take the starting point for x plus my fractional distance, which is 1/3, times the difference between the two, the distance between my two x's. And how far did I go from -2 to 7? Well, this is x1, this is x2. So I'm going to do 7 minus -2 because this is x2 and this is y2. Okay? So I've got -2 plus 1/3 times 7 plus 2, which is 9, which is -2 plus 3, which equals 1. So the x-coordinate I'm looking for is at 1. That's the point that's going to be 1/3 of the way from here to here. So let's take a look at the y's. All right, for the y values, I'm going to take y1, that's my starting point, which is 0, and then I'm going to add my fractional distance, which is 1/3, times the distance the two y's are apart. Here's y2, y2 minus y1. So that's going to give me 0 plus 1/3 times 11. And 11 times 1/3 is 11/3. So that is going to be, which is about 3.3. Or sorry, 3.7. 3.7, my bad. 3.7, because you get 9 2/3. Or, sorry, 3 2/3. So that's my distance, 1, 3.7, if you want to do it with decimals. Now let's check it out using the longer method we did up there. All right, so what I did was for my x, I took the absolute value of the distance, which is -2 minus 7, the difference here, and I got the absolute value of -9, which is 9. And for my y value, I took the absolute value of the difference, 0 minus 11, which gives me -11, which is 11. So that's the full distance. But we're looking for what? 1/3, right? So I'm going to take 1/3 of 9, and that's going to give me 3, and 1/3 of 11, and that's going to give me 11/3. Now, if you look back up at the previous example, after we found how many units, 4 units and 6 units, we just added those units on to our start. So I've got 3 units, and I've got 11/3, or 3.7 units. So I'm going to add those on to my originals. Where did I start? I started at -2, 0. So I started at -2 for x and 0 for y. So I'm going to take -2, and I'm going to add the 3, which is 1/3 of the full 9, and I get 1. Same as up here. I'm going to take the 0, and I'm going to add the 3.7, which is the same as up here, where I did 4 plus the 6, and I'm going to get 3.7, which is the same. So that is how you do fractional distance.